Okay, sorry that I'm repeating myself right now, but I just started recording this lesson. I'm going to try and do that. We are starting with section 1.2. We're going to finish that today. So we worked on a couple problems, and we're going to finish 1.2 today, and then go on to 1.3 and 1.4. Okay, 1/8 is this. Let's figure it out. Emma, what did you multiply 3/2 by to get the same denominator?
The 4.
Very good. So you multiply by 4. Once you do the denominator, you have to do the numerator. So you got, not 6, 12/8. Good. Plus negative 11/8. And then 12 plus negative 11 is 1/8. Does that equal negative 1/8? False. Okay. Now, over here, decimals are not too hard to work with, but I know some of you are more comfortable using calculators. I'll show you really quick how to do it without a calculator. Really, you can say 9.5 minus 3.8. That's a quick way. I just take the positive minus the plus the negative. So plus and negative is like subtracting. So you borrow 1. So this now becomes 15, so you've got 0.7 and 5.7. So yep, 5.7 is equal to 5.7, so this is true. Okay, now we're going to get into subtracting sign numbers. And this is what I say. The easiest way to subtract two numbers is to change subtraction to addition, and then change the sign of the second number, or its opposite. Once you've done that, you can then use the rules of addition because you've changed it to an addition problem. So let's look at the first one. 2 minus 3 can really be 2. Say 2 minus 3. You change subtraction to addition, and then you change the opposite sign of 3. So instead of positive 3, you put negative 3. Change your color to yellow if you've seen this before. And now it's an addition. So now we look up here, we've got a positive plus a negative. Oh, we have to take the sign of the larger and then subtract. Very good. So negative 1 is the correct answer. Let's look at negative 2 minus 3. So negative 2 minus 3, you take that to addition and change the sign of the second number. So it's really negative 2 plus a negative 3. Very good. Negative 5. Okay. Negative 2 minus a negative 3. So if we change subtraction to addition, we have to change the sign of the second number. And I'm just going to do that here so you guys can see what I did up here. So what's negative 2 plus 3? 1. Good. So just be careful. Sometimes when you make all those little tick marks, they do get a little confusing, so you might have to rewrite it. Okay, and what about the last one? So negative 2 minus a negative 3 is really like saying negative 2 plus a positive 3. Oh, I goofed up. It doesn't start off negative, does it? Sorry about that. So 2 plus 3 is equal to 5. Did I get it right that time? Okay, so how do you guys feel about that? Oops. You okay? Change your color to green if you feel comfortable with adding and subtracting sign numbers. Change your color to green. Okay. Sunny is green, thank you. Okay, let's go on. Now we're going to, in your homework, there's some problems that have multiple things to do. So if you look at the bottom of that third page, it says, simplify each. So all I want you to do from right now is to go left to right. So let's look at this. What's negative 3 minus 2? Or you can say negative 3 plus a negative 2. Negative 5. Then copy down the rest of it. So plus 6.2. What's negative 5 plus 6.2? So think if you have $6.20, you're going to take off 5. Be careful, we're not multiplying. We're taking off 5. So $1.20. Good. Okay, go left to right, left to right. 5 minus a negative 4 is really like saying 5 plus positive 4. So 9. And then I'm just copying down the rest. I know this seems tedious, but if you do it wrong, it's going to get a wrong answer. So 9 plus 22 is 31. Bring down this other minus 31, and you are correct. 0. Good job. Okay, now I say work from left to right first, but really you should always simplify an absolute value. So what is the absolute value of negative 8? Positive 8. Good, so 14 minus 8 is 6. Okay, so you'll have some homework problems like that. Okay, also in section 1-2, we're going to talk about multiplying and dividing real numbers. Multiplying and dividing real numbers. So this one I think a lot of people like. A positive times a positive is positive. A negative times a negative is positive. It's not the same as adding. A positive times a negative is negative, and a negative times a positive is negative. Okay, the same rules apply as multiplying and dividing. So positive divided by positive is positive, and negative divided by negative is positive. Positive divided by negative is negative, and negative divided by positive is negative. Okay, so let's look on the right-hand side. 5 times 6 is 30. Negative 5 times negative 6 is also 30. 5 times negative 6 is negative 30, and negative 5 times positive 6 is negative 30. I think people like multiplying and dividing sign numbers better than adding and subtracting. Okay, without using a calculator, it might be easier to change division so that it looks like a fraction. The first number always goes on top, the second number always on the bottom. Well, some of you can just do this in your head. 22 divided by 11 is 2. Negative 22 divided by negative 11. A negative divided by negative will change to a positive. So then you get 2 again. Now this is where I definitely like to look at it as a fraction. 11 divided by negative 22. Well, why don't we just leave it like that? No, you have to simplify your fractions. So we're going to divide top and bottom by a common divisor. What's that common divisor? What goes into both 11 and 22? Okay, besides 1. You're right, though. 1 divides into everything, but 11. So 11 divided by 11 is 1. And I bet you that's what you were thinking of, Naomi. And negative 22 divided by 11 is negative 2. Do not leave your answer with a negative in the denominator. Either put it in the numerator or leave it out to the side. But do not leave a negative in the denominator. Okay, last one. Negative 11 divided by positive 22. Again, always want to simplify your fractions, so if any number can go into both the numerator and denominator, make sure you do that. So negative 1/2 as well. Okie doke. Going on to the next.
Miss Parker. Okay, so if there's a negative number on either the top or the bottom, it's going to be like a negative fraction?
Correct. You're right. So if there's only one negative and one positive, your answer is always going to be negative.
You don't flip them or anything like that?
I think what you're thinking is, let me see if we're doing it here. Right down here, the very last examples we do today is what you're thinking of. We'll get to that, Lacey. If you change division to multiplication, you flip the second fraction.
No, I'm talking about like that 0 over negative 21. Like, would that just be...
Oh, that's different too. 0 is different.
It's just like, you know how you have that 1 over negative 2?
Yes,
And that just equals negative 1/2?
correct.
Wouldn't it be, you would have to switch that and it would just be 2?
No. Nope. Because if you think about this, think of it as just 11 over 22. Okay, I'll erase this in a minute.
Okay.
Let's say we're taking a survey, and I said 11 students out of 22 go to bed before 9 o'clock. Well, what ratio is that? If I say 11 students out of 22 go to bed before 9 o'clock, what ratio is that?
It's 1/2.
Very good.
Yeah.
So if you were to say 2, that doesn't make sense, right?
Yeah, no, it doesn't.
Okay. So if you kind of think of it sometimes in word problem, I know you guys don't like word problems, most people don't, it might make a little bit more sense that way.
It just throws me off that negative sign on either the top or the bottom.
Okay, so let me show you this. If I have negative 5 ninths, like that, and the negative's way out on the side, when we get into slope, it'll make a little bit more sense. But this negative can go either to the numerator or it can go to the denominator, but just not both.
Okay.
So when there's a negative on the outside, it either means negative in the numerator or denominator, but our final answer would either be one of these two. You just don't leave a negative in the denominator.
Okay.
Okay? All right, and I'll erase this stuff in a minute, but I'll leave it up there for you to look at. Okay, this next little area is asking you to do product means to multiply, and quotient means to divide. So the first four are products. The last two are quotients. You're dividing. Okay. The first one is a product because really there's an invisible. Oh, John, yeah, that's one way to think about it. You have to be careful though, John, when you just have to remember, like the first one, a negative times a positive, right there. John knows that his final answer is going to be negative. But if you look over on the fourth problem, what's a negative times a negative? What's a negative times a negative? Positive. So he knows that his answer is going to be positive for that problem. Okay? So I like that, Sean. Sometimes that is helpful. You really don't have to worry about the sign. You can just bring it straight down to your final answer. Okay? The second problem, a positive times a negative is going to be a negative. So your final answer is going to be negative. Now, the trick to the third one, does anybody know the trick when you multiply anything by 0? What's going to happen? 0. So that's your answer for the third one. You're done. You're done. When you multiply by 0, it's 0. Okay. So let's look at this first one. When you have something times a fraction, an easy way to do this is put the first number over 1. Now, so we really have negative 16 over 1 times 5 over 32. When you multiply fractions, you could go straight across, but you're going to get really big numbers, and you're going to have to simplify anyways. So this is how I simplify. I look at any numerator and any denominator. Can you divide, does any number go into 16 and 32? 16. So you could either say divided by 16 and divided by 16, or you can just cancel it out. 16 goes into 16 once, 16 goes into 32 twice. That's kind of a shortcut. So you really have negative 1 over 1 times 5 over 2. And then when you multiply straight across, you get negative 1 times 5 over 1 times 2, which is negative 5 halves. That's the first one. Now, I showed you a lot of steps. You don't have to show all those steps. I'm just kind of showing you, more so that if people need it, they can take it. Now, we just said the next answer is going to be negative, okay? You can do this longhand, or I'm okay with you getting out a calculator. Does anybody know what this answer is? We already said it's negative. What would you say? Good. Negative 9.12. Very good. Okay. Now, look at this fourth problem. It's kind of similar to the first one. Can we cross things off with any numerator and any denominator? 2, right? 2 divides 4 and 2. Good. 2 goes into 2 once. 2 goes into 4 twice. So what we're left with is negative 3/4 times negative 1/5. Now, no other numerator is going to cross off with the denominator. So we're just going to multiply straight across. Negative 3 times negative 1.
It's actually negative 3 halves.
Oh, thank you, thank you, thank you. Thank you very much. Yeah, I would have gotten a wrong answer, right? So now we just said our answer is going to be positive, and look what happens. Negative 3 times negative 1 is positive 3. And the denominator, 2 times 5, is 10. If you are having problems with fractions, you need to go to academic services right away. These are things that we're expecting you just to know right off the bat, know how to do very quickly, but it is very common for people to forget how to do fractions. Okay, we just don't have the time in class to spend a week on fractions. So you need to go to academic services and have them help you with adding fractions, multiplying fractions, dividing fractions, and subtracting fractions. Okay. All right, now, this next one is division, or quotient. If you want, you can think of it as negative 36 divided by 6. And I think it was John who said earlier, don't worry about if it's positive or negative. Just think about what is 36 divided by 6. What is 36 divided by 6? Good. And a negative divided by positive is negative. Done. Okay, last problem. Answer positive or negative? Positive. Good. I'm okay with you using a calculator, but if you don't, you could do long division. 0.4 divided into 12.56. Just move your decimal over once, and you could do long division. Bring down the 5, goes in once, remainder 1, bring down the 6, it goes in 4 times. So your answer is positive 31.4. Almost just as fast as if you were to use a calculator. Okie dokie. That is multiplying and dividing numbers. Now we're going to look at this definition called multiplicative inverse. Multiplicative inverse is a fancy word for saying reciprocal. Does anyone have any daughters that read Fancy Nancy? Change your color to red if you do. No? Okay. It just made me laugh because in these Fancy Nancy books, they say that's a fancy word for. So multiplicative inverse is a fancy word for reciprocal. Reciprocal just means to flip the fraction. Flip your fraction. It does not mean to make it negative. It just means to flip. So let's start off with the number 4. It's not really a fraction right now, but I can always make it a fraction by putting it over 1. So now the multiplicative inverse, or reciprocal, is 1/4. Okay, 0.3 is a decimal. So 0.3, how do I make that a fraction? What is 0.3? 3/10. Good. So what is its reciprocal? 10/3. And leave it 10/3. Don't change that to a mixed number, which is 3 1/3. Don't write that. They just want you to flip it, and that's it. Okay, what about -5? Okay. just put it over 1. Oh, how do you make 0.3 a fraction? It's read 3/10. So if you look at this, it's read 3/10, so I know it's 3/10. There is a button on your calculator, though, that will change from decimal to fraction. I think it's like D arrow F and F arrow D. All right, so this one I saw someone say -1/5. And the last one is probably the easiest because it's already a fraction, so -8/5. But notice there's still a negative. So if it says reciprocal, you just flip it. Keep the same sign. Keep same sign. Okay? Why -1, not +1? Where are we? Well, really, this negative, it could either go in the numerator to the denominator or out to the side. So some of you might write 1/-5 because the negative was originally in the numerator and now it goes to the denominator. But remember, we don't like negatives in the denominator. So you can always pull a negative out in front of the fraction and it means the same thing. Does that help, Jessica? Okay. All right. See, these little things, you wouldn't know if you just read the book. I mean, that's why I like you guys coming to class, because you're going to see, you're going to ask questions, I'm going to answer them, and it's just these little things. If you get cleared up, it'll help a lot. Will we ever have questions? When we get to slopes, honey, when we get to slope, and that's chapter 3. Yep, so chapter 3. Don't worry about it right now. Okay. All right, now we're going to find quotients. Now here, I tell you how to do it right here. Quotient means division. When you have fractions, you always want to change division to multiplication and then take the reciprocal of the second number. You flip the second number. So look at the first one. It's 16. Instead of divided by, I'm going to say multiplied by, and then I'm going to flip this one, -5/3. Change the color to red if you remember this. Okay, and if you don't, it's okay. It's been a long summer, right? Now we're going to go back to about halfway up the page. If you don't have a fraction, just make a fraction out of it. That's okay. Now it's easier. Now can you cross anything off? Does 3 go into 16? No, not evenly. So what you do then is you just make one numerator and one denominator. So 16 times -5 is negative what? 80, and 3 times 1 is 3. So there is an acceptable answer. That's an acceptable answer. Okay. If you want to change it into an improper fraction, that's fine too. All right, next problem. The first number always stays the same. Division goes to multiplication, and we're going to flip this guy. How do we flip this guy? So I can always put 1 underneath a number, and now it'll help me to flip. Very good. And it stays the same sign. Keep the same sign. Okay. Now, can you cross anything off as far as numbers go? 2 goes into 8 4 times. 2 goes into 2 once, 2 goes into 8 4 times. So what we're really left with is -1/3 times -1/4. And I believe it was John again that earlier said negative times negative is positive. You don't have to write this out. You can just think it in your head. 1 times 1 is 1. 3 times 4 is 12. You normally don't put the symbol positive in your answer if it's a positive answer. Oh, look at this next problem. Craziness. This is called a complex fraction. Why is it called a complex fraction? Because it's a fraction and it's very complex. If something's complex, it's like complicated. Well, we've got fractions within fractions, right? Holy moly. So we have fraction in the numerator, fraction in the denominator. You're saying your fraction in the numerator divided by the fraction in the denominator. So we're going to write it like that. Fraction in the numerator divided by, that's this line here, fraction in the denominator. Go ahead and write that down. Now it's like what we were doing before. You're going to take your division and flip the second fraction. So negative 10/7 still stays there, but times 5/24. What can I cross cancel? What goes into 10 and 24? What divides into 10 and 24 evenly? 2. So 10 divided by 2 is 5. 24 divided by 2 is 12. Okay. I am just going to rewrite what I have. I have negative 5/7 times 5/12. That's what's left over. Can I cross off those two 5s? They're both 5s. Can I? Why? Why can't I cross off those two 5s? Why can't I cross them off? They look the same.
Because they're both in the numerator.
Good. So one has to be in the numerator. John, that was you, right? And one has to be in the denominator?
Yes.
Very good. Thank you. So the only thing I can do is multiply straight across. A negative times positive is negative. 5 times 5 is 25. 7 times 12, anybody know? 84?
84.
Perfect. So there's my answer. Okay, and then the last two problems are dividing with 0, and I put them on there on purpose. So put a star next to them. If 0 is in the numerator and you're dividing by some other number besides 0, your answer is always 0. If there is 0 in the denominator, then your answer is undefined. Very good, Tish. Very good. So if you have a 0 in the denominator, it's always undefined. Okay. That's those problems. Now, yesterday at the end of class, some people stayed and there was a question of how to change an improper fraction to a mixed number and so forth. I did this with this person. So if you want me to go over at the end of class today, I can as well. But we're going to have to go on to the next section. So just so you know, you do have, this homework is due tonight for sure. Okay, and I am not collecting any work. Tomorrow's assignment, though, I will collect work. So I'll go over that when we're done with that section. Okay, so now we're going to go into worksheet 1.3, 4, and you should have printed that out for today. I mean, you can print out your own notes. I'm going to save it so I know which one's my writing on. Okay. Now, in Chapter 1, Section 3, we're talking about exponents, roots, order of operations. In Section 4 is going to be this real number properties. Okay, so again, we're kind of going through it fast because this is supposed to be a review, but you know, I understand summer is kind of a long time. So let's go through exponents. Any questions right now? Because I know I'm just kind of going right through the material. Questions? Okie doke. So Chapter 1, Section 3. Exponents. When you multiply a number by itself so many times, you can put it in exponential notation. So 3 times itself 4 times is 3 to the 4th power. 2/5 times itself 3 times is parentheses 2/5 to the third. Do not write 2/5 to the third like that, because what that looks like is only the 2 is to the third power. So by putting those parentheses there, it means the whole thing is to the third. So when you're writing in your homework, make sure you understand that. With fractions, put parentheses around it. Also, if you have like a negative that you're multiplying by itself twice, make sure that whole number goes into parentheses. And again, not negative 4.1 squared. Because the trick about exponents is exponents are like these tiny little creatures. It's weird when I describe this, okay? They are very small. They can't see very far, but they're very smart. So these exponents can see what's right below them. Well, it knows, it sees parentheses, so it's saying to itself, I'm going to multiply whatever's in parentheses by itself 3 times. 2/5 times 2/5 times 2/5. Over here, the 2. The 2 sees the parentheses, so it says, I'm going to multiply whatever's in parentheses by itself 2 times. Negative times negative. If you were to just do this, it's only seeing the 4.1. It's not squaring the negative. Here, it's only seeing the 2. It's not taking 5 to the third power. Okay, and what about the last one? H to the what? Good job. Fifth, right? Probably just didn't count right. Okay, that happens. Okay, now this is where we're going to get into where it gets complicated. Oh, and by the way, in your homework, some are just going to say write it in exponential notation. You don't go any further than this. Okay. Exponential notation means there's a base. The bottom number is the base. And this exponent little guy is called the exponential or power. Okay, exponents could be called powers. All right, going down evaluating each. Okay, let's look at these. 5 squared really means 5 times 5, which is 25. Negative 5 squared in parentheses. Remember, this guy is smart. He knows whatever's in parentheses is going to be multiplied by itself twice. So what's a negative times a negative? Positive. Okay, now look at this next one. This 2 only sees the what? 5. So it's really saying the opposite of 5 squared. That is different. So this is the opposite of 25, which is negative 25. Change your color to yellow if you understand that. This is a hard concept. This is a hard concept. Okay. Emma, Danielle, Amanda, and Jessica, how are you doing? Okay, I want you to practice right here. You practice those 3 problems, 2 to the 4th, and so forth. And then I want to talk to Emma, Danielle, and Jessica. Okay, so remember this little exponent applies to what's below it, and here it's the parentheses. This is just to the parentheses. This 2 only sees the 5. Whatever's right below it is the 5, so it only applies to the 5. Okay, thanks, Jessica. You'll get better at that. Okay, do the next ones, and I want the answers to the next ones. I'm taking roll right now, and I don't see John Jerichowick. Is that correct? John Jerichowick is not here, or Isiosa. Oh, that's not good. Okay, make sure you're here every day. All right. Woo, Natisha gave me everything. Okay, so let's look. 2 to the 4th, yes, is 16. That is 2 times 2 times 2 times 2 without the parentheses, same as with the parentheses 16. This is negative times negative times negative times negative. And negative times negative is positive. And then when you do another negative, that's a negative. Then when you do another negative, it's a positive. So that's also positive 16. Okay, this really means the opposite of 2 to the 4th. We just figured out 2 to the 4th is 16, and the opposite of 16 is negative 16. So over here, I have these little rules. If you have a positive in parentheses to an even exponent, you're always going to get a positive answer. If you have a negative in parentheses to an even exponent, that's this one right here, negative to an even, you're also going to get a positive. But if it's in parentheses. All right, now let's look at odd numbers, odd exponents. So 4 to the 3rd really means 4 times 4 times 4, which is 64. Oh, I bet you that's the one that you were doing, Derek and Jessica. Okay, negative 4 to the 3rd is negative 4 times negative 4 times negative 4. Negative times negative is positive. Positive times negative is negative. This guy means the opposite of 4 to the 3rd. So the opposite of 64 is also negative 64. Sorry, I had to cram that in there. So when you have a positive to an odd power, it's positive, but when you have a negative to an odd power, it actually stays negative. Okay, we're going to go down to this one right here. That one looks a little different. This one is really, actually let's do this because I have more room. Maybe we'll do both. The opposite of, now what is negative 2 to the 3rd? Negative 8. And the opposite of negative 8 is positive 8. And Jacob, you would do one more, negative 2 times negative 2, because there's 3 in there. All right. This one is saying the opposite of negative 3 to the 4th is positive. 3 times 3 is 9 times 3 is 27 times 3 is 81. And the opposite of 81 is negative 81. No, that's fine. That happens. Okay. I left you guys, I did not fill out this table on purpose. I want you to do this at home tonight. If you want to do it right now very quickly, that's fine. But let me just explain it. These are all the numbers, just regular numbers. Squared means like 2 to the 2nd power is 4. Cubed means 2 to the 3rd power is 8. That means 2 times 2 times 2. This is 2 to the 4th, 2 to the 5th. No, Tish, on that, because we're going to learn order of operations in a minute. You have to do exponents first, and then you do the negative afterwards. So you have to do exponents first, and then you can do the multiplication of the negative. Okay. The next one is 3 squared, and you can just go down. 4 squared is 16. 5 squared is 25, 36. I want you to do as many as you can. 3 to the 3rd, 9 times 3 is 27, and so forth. Okay, I'm going to let you guys fill that out on your own. Take out your calculators, and you're going to have to, and I told you we wouldn't really use calculators this week. I lied. If you have a calculator, go ahead and put this in your calculator. You're going to type 0.863, then your caret button, or you'll see an x to the y. That gives you the exponent. And then you put in 2, and then hit your enter button. Tell me exactly what you get. Tell me exactly what you get. Okay, now is that exact right? You did not round, 0.744769? Okay, don't round unless they ask you to. Now, the bottom one, you can, very good, you can put that in your calculator as a decimal, but if it starts as a fraction, then your answer should be a fraction. So I want you to practice this as a fraction. This is 3/5 times 3/5 times 3/5 times 3/5. Or 3 to the 4th in the numerator, 5 to the 4th in the denominator, right? You're multiplying 3 times itself 4 times. So if you did the 4th power over here, 3 to the 4th is 81. What's 5 to the 4th? Anyone get that far? What is 5 to the 4th? Good. So if you have this chart filled out, oh, it's 81 over 625. I like this chart because you can go back to it and refer to it very quickly, and the more you use it, the better you're going to get at memorizing this stuff. Now we're going to get into radicals. Now I actually like to use this square chart with radicals because you're using it backwards. Okay, so I'm going to go down here. That's really what radicals are. They're the opposite or the inverse of squaring a number. Taking the square root. Excuse me. So I'm going to do a simple one. Let's do the square root of 25. So let's go up here. Square root of 25. Well, if it's opposite of squaring, then I'm going to look at 25, and the square root of 25 is 5. So that's how you can use a perfect powers table. So square root of 25 is 5. Does anybody know the square root of 169? Good. Okay, so if you were to square 13, you get 169. When you take the square root of 169, you get 13. Okay, now let's look at, this is the opposite of the square root of 225. Did anyone, what is square root of 225? Is it 15? So the square root of 225 is 15. So this is negative 15. But look at the difference. The negative is on the inside of the third problem or fourth problem. The square root of negative 16 is not real. Try it on your calculator. Click the square root button, then type in negative 16, then type in answer. You're going to get error. Well, you're right, Derek. You are very, very correct. We just are not getting into imaginary numbers right now. So this is technically an imaginary number, but we'll just for right now say it's not real. Okay? Something like the next one is the square root of 25 over the square root of 64. Square root of 25 is 5. Square root of 64 is 8. This next one, you're definitely going to need a calculator. And it says for decimal answers round near 1,000. Someone give me the full answer. What's the square root of 5.4? What's the square root of 5.4? Jake is going to give me the answer. Anybody else can type it too. Okay, 2.23, oops, 323790008. Okay, the nearest 1,000, does anybody know where that is? 3 decimal places. So you look at this guy, if it's 5 or higher, what do? You round up. You round up. Very good. Okay, so you round the 3 up to 4. Okay, so for your homework, you can do everything up to here in 1.3, 1.4. But I have you, if you look at the bottom, so once you get to order of operations, it says like simplify. You may not be able to do those problems yet. That's where we're going to start tomorrow. If you look at the bottom of this worksheet, it says that you have to submit your work for these problems, 13 through 20, 23, and 24. I will show you where you're going to submit it. I'll talk about that tomorrow. So remind me to tell you about that, but for those problems, I want you to do it nice and neat on a piece of paper. If you want to show work for all problems, I'm okay with it. Okay, but I bet you these problems will start with order of operations, so we'll have to wait till tomorrow anyways. Okay, so I will see you guys. If you want to stick around and ask questions, that is fine. I know some of you have to get to class, so we will eventually. Melody, you're still going to do the homework online in my math lab. MML is for my math lab. But for 1.3, 1.4 homework, I want you to submit some of your works. Correct, Jake. And Sarah, this is for right here, homework 1.3, 1.4. So let me show this screen. In our My Math Lab assignments. Shoot. Let me go back into our class. No, okay. So always go to your assignments, and this is how I check. Go to the assignments button, and then click show all, and the due dates are right on the left there. So today's the 28th. 1.1, 1.2 is the only one that's technically due tonight, and I'm not collecting your work for that. 1.3, 1.4 is due tomorrow night, so I'm collecting your work for some of that tomorrow. Okay, and we'll talk more about that tomorrow. But make sure if you do work ahead, that you do your work for that.
Okay, so Mrs. Parker,
Yes.
all the homework we need to get done tonight is the stuff that we worked on yesterday, right?
Well, yes. So every time we do a lesson in class, that night you go home and you work on it. Okay?
But you gave us an extra day, though, because we didn't get through the stuff that we were learning.
Correct. So by the end of this week, hopefully we'll be caught up. And, that's okay if we're just a little behind. So okay. I'll always have, the homework due the next day. How about that? After we talk about it.
Okay, cool.
All okay. Right. And go ahead and just work on your homework assignment for a minute. I have to work on something for the next couple of minutes, okay? But I'll be here.